So in this section, I'd like to show you how Git works under the hood. Sometimes it's important to understand what happens in the background if you would like to like resolve some more complicated issues. And in this first video, I will briefly tell you how our commit stores. So practically, as we already discussed, a commit has a commit message, an author, a committer, a timestamp, a parent which is stored by its hash, and a content stored by Git objects. So this first part is, I would say, pretty trivial. They are just simply strings or a timestamp. The parent is stored by its hash. It's also not that difficult, but then the content stored by Git objects. This is the tricky part. So how is the content stored? So a Git object can be four different things. So it's either a tree. A tree is like a tree of other Git objects. So this can represent a further structure. This can just connect different Git objects together. So for example, if inside one commit you modified multiple files, then this commit will have a tree as a Git object, which refers to the different file related changes, which are stored in blobs, which are binary large objects. I mean, practically these are binary files, and these represent the change in one file. You can, if you use the git diff, that more or less shows you how they are stored. Then you have tags. So we already learned about tags. This is, so if you have a tag on a commit, then it's stored even as part of the Git object in the tree. And the last specific case that a Git object can be even an other commit. And when is it the case? Yeah, I mean, you already learned about that. This is when you're using Git submodules, then it refers to a commit of another repository. Then that's stored also as a specific Git object. So that's how Git commits and more specifically how Git objects are stored. Oh well, it's, I think, something like nice to know. So thanks for listening.